Last week we started with the Earth engine and we did an overview of GE and we also did an introduction to JavaScript. Yeah, and I think we got to the data types and we had to pause. Yeah, so today what we are going to do is to go through the data types. Then if there is enough time, we'll move on to the next section. That is the image collection, feature collection, and the introduction to, how you can, um, how you can do the filtering, reducing, mosaicing, cloud masking, clipping, and so on. So we'll be tackling each of these items that are listed here. Then yeah, so I'm praying by next week we should be able to tackle all of these. Yeah. So I'll quickly go to my PowerPoint where we left off. Then we will continue. I think we got to slide 10, if my memory serves me right. Yeah, I think we got here. All right. Yeah, so as I made mention earlier, so last week we went through all these JavaScript data types and I explained these items, right? So I think I touched base on it, but I didn't go into the details. So we are going to touch each of these data types. Then we'll say the session is going to be a presentation slash a practical session. So when we take each slide, we will go to Earth Engine, then we'll just have some one or two practical session, then we'll continue. Yeah, I think that will help. All right, so the first item I would take is string. And as we all know, we've done Python, we've done JavaScript, and um, during our class in JavaScript, we learned about string. During our class in Python, we also learned about string. So usually, string cuts across, like these data types cuts across all programming language. And JavaScript, the Earth Engine, the code editor being which is being run on the JavaScript API. We are going to use the JavaScript, right? So in JavaScript, like using variables. So with a string, for instance, um, anytime you see any item in a code that has double quotation or single quotation, that item is a string, right? So these, whether being double or single quotes, these can be used interchangeably, right? So you shouldn't be confused. And one thing that I would also want to touch base on is variable, which I forgot to talk about it. So variables, and in us, I'll go again in our JavaScript and in our Python, we kept mentioning variable. Usually, variable is like a container, and I think I explained it in our uh, previous sections. So it's like a container that holds like entities or that holds items. So anytime you want to call those items or those entities, you can just call the name of the container. That is the variable, right? And variable usually stores like objects, and it's like it's usually so it stores objects and it makes your code more readable. Let me cite an example here. Let's come to our code editor. So let's say I'm declaring a variable. So I'll say a variable called uh, my numbers, right? And I say, okay, so in my code, I have this list. So anytime you see the square brackets, is a list. The entity is a list. So anytime you see this anywhere, you should just click your mind that it's a list. We'll be getting to that bit. So variable, so I've declared a variable here called my numbers. So anytime in my code, I want to call these items, or I call this list, there's no need for me to retype the whole thing again. I can just call my numbers and you get your item. So let's say when I say print my numbers and I run, I'm going to see the numbers printed here, which means that this is holding this list. Okay, so let's continue. And in the same way, when you come to F engine, right? In Python, in the JavaScript, there is a way, like you have a way to declare a string. In F engine too, there's a way to declare an F engine string, right? And we are going to look at that. So as you can see here, this is an example of what I just mentioned. When you see a single quotation mark, so a quoted item, it refers to a string, a double quotation. So these are used interchangeably. Okay, let's move on to the next slide. So as I made mention, in F engine, if you want to declare a string, right, it's simply you do ee.string, as you see here, ee.string, then you put your string item in there. All right. So that's how strings are usually declared in the F engine environment. Right. And like so, usually the EE is like a container. So when you see this EE, so the EE, so let's take this one for instance, this example. Right. So this EE dot string is like a container on the F engine server, right? So anytime you declare that and you click on run, it runs that particular item on the GE server. But when you declare it as this one, like as a normal string, it only runs in the user interface, right? Okay. So we'll get to that when we get into the where we'll be running those codes. I'll show you, I'll prompt you some of the things that the items that you can apply some of these things to. All right. So let's move to numbers. Okay. So as we have numbers, when when you're writing a number in any programming language, you don't need any quotation marks. So let's say I'm declaring a variable called AB, and I'm saying that AB is equals to 67, and I'm saying var BC is equals to 89. So you can see the numbers, the moment you bring a quotation. Oh, so you see anything like this. Oh, my keyboard is this. All right, you see anything like this. This is a string. This is a number. Okay, so if the number is in a quoted sign, is a string, it ceases to be a number. Okay, so that should be the difference. So when I try to add this and that, I'll get an error. Let's try something out. So I'm saying var C is equals to AB plus BC. Okay. And I'm saying that print C. Let me comment this. So in JavaScript, if you want to comment anything, you use the double forward slash to comment the item. All right. So are you seeing what it printed? So you can see that it is 67 plus 89. Instead, it appended this 89 to the 67 as a string, and which is very wrong, right? But the moment I remove the quotation mark or quotation sign from the 67 and I run, I get the answer. So these are some of the mistakes that you might make. So each time you are writing the code, you are inheriting anyone's code. Let's try as much as possible to pay attention to these details so that if there's an error that is running through the person's code, you will be able to look at it and correct that. Or else that error will also run through whichever product that you are trying to compute. Okay. Okay, let's continue. So as you can see here, I declared a variable called men, and the men are 42, the women are 20, and we want to find the total. And as easy as that, you do men plus women, and you get the total, and you can print it out. You can print the output. All right. Okay, so in Earth Engine, if you want to declare a number or create a number object on the server, the only thing you need to do is to do ee.number and you put the number in there, right? And it's as easy. So this is a typical example. This is a constant e. Yeah. So in another example, you can do ee.number, then you put the number, let's say 54 in here. So this you are creating a number object on the GE server, right? Okay, I wouldn't waste much time on these items so that we can quickly get to the real stuff. All right. So I made mention of lists earlier, right? So this is an example of a list. So it's just like what I created in my previous example. So when you see any square brackets, it's a list. Like when you see square brackets with some item in there, either in Python, in JavaScript, in any language, is a list. Right? When you see the items with the bracket, it's a tuple. Right? And I think we touch base on that when we're going through our Python introduction to Python. I think Jed took you through these basic data types. So I wouldn't waste time to explain these items. So I just cite an example for each of these items. So this, like as you can see here, this is an example of a list, right? And in the same way, if you want to create a list object on the server, GE server, the only thing you need to do is to use the ee.list, like what you see here. So you see ee.list, then you put in your list in there. So in this, you create your object, your ee list on the object on the server. Okay. All right, let's move on. And one of the things that I want you to take your time and understand is this: the object or the dictionary. These are used interchangeably, right? And these, or somebody may ask, what is objects or what is a dictionary? So, like, dictionary are usually key value pairs. So when you see in the script or in your code or some of the results, when you see anything like this, so a curly bracket with a key and a value, a key and a value, a key and a value, it's an object or a dictionary, right? And usually it's being created using what? The curly brackets, as you see here. So let's get uh some practical session here with the objects. I really want you to understand this object, which will be used most at times when you print some of the output in Earth Engine. Okay, so I will say I'm creating an object called bio, right? And this object will have name, and I'm saying name will be a string. So I'll say Ernest. And I'll say Ernest, I'll say age. I will say 12. And each of these items should be differentiated or like separated by a comma. So after the first key, the value pair, you separate, like you end it with a comma, then the next value pair comes in, right? Oh, I made a mistake, sorry. I made a mistake. Oh, all right. And I will say house at. So house address, and I'll say I just put in anything there. Ghana. Oh, why do I keep putting equal sign there? All right. So what you see here is just an object that contains a bio of a person. So over here, when I come here and I say print bio, you see what is printing. So you have an object and it says what? It has what? Three properties. So let's open. So you can see that the object bio has three properties, and the properties are age, house, add, and name. And can you notice something here? With dictionary, it doesn't keep the order in which you use in creating. So you can see over here, I created the object with the name at the top, the age following, and the house at the bottom. But when I printed it, it has reshuffled it. All right. So the order is not important because usually you call the items by their keys, right? You call the values by their keys. All right. So let's go back. All right. So let me also run another example. So someone will ask if we want to call a certain value here. So let's say we need this 12. right? How do you do it? So you can call it by bringing a square bracket, then you bring this, either single or double quotation, and you call the key. So let's say the key is H. So let me comment this print. So when I print it, I get what? 12, which means that I'm calling the key H, and it's going to print 12. Same for name, same for house art, right? Okay. So this is a little I would say about objects. Maybe when we start exploring the data, we will see some of the applications of these examples that I've just shared. So in the same way, in Earth Engine, if you want to create a dictionary object on the server, the dictionary created on the server. All right, let's move on. So I just brought this table here just for those of us who might be confused between the list and the dictionary. When you look at the structure itself, the structure of the F and the two, being it the dictionary and the lists, the structures, the way the structure is, you will see the difference. The list comes with a square brackets, and the dictionary is enclosed in a curly brackets. Right? And you can see, as you saw, the dictionary comes with a key and a value. When you check the list, yeah, the values are in the text. So when you check the list that we print here, it kept the order. So when I print this, it's going to print out exactly like this same order that I used in create this one. So you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 123, 124, 125, 126, So dates in our scripting, what is not a lot of scripts, right? So anytime you want to specify, like you want to call a particular date in the scripts, what you to the is so it's
Hello. Hello. Hey, talk from your end. I can't hear you. I can't hear you.
you can't hear me. Please, can anyone
Yeah.
hear me? Also, please, can you hear me?
Yeah, Ernest.
Please, can you hear me?
It's not that clear.
Okay. it okay now?
Yes, please.
Okay. Thank you, Elvis, for the feedback. All right. So, and if you want to get the current date in JavaScript, it's date.now, right? In JavaScript, if you want to get the current date. So when I say print date.now, so it's going to give you the date in this format, but you need to do what format that to a format that you need, right? Okay. All right. So let's move on. There are arrays which is the same way. If you want to declare an array in FEngine, we use the ee.array to declare that. And array are lists, like nested lists. So like it's like a group of lists that has been put together, right? That makes an array. And you'll be seeing a lot in our subsequent sessions. All right. So let's take functions. We will be writing a lot of functions. I like using functions because it makes your code more organized and clean. Right. So let's say you have a certain process that you keep running in your code, right? A certain process you keep running in your code. You keep repeating that code in each of these lines. So what you can do is to write a function and give it a parameter so that anytime you want to use that function, you call it, then you pass the parameter to it. So a typical example is what you see here. So you have the function. So it can be declared in two different ways. This is one example. You can declare a variable with a function name, right? Then you bring the function, then the parameter. How many parameters are you passing through that function? Then you bring your statement, and always a function should return like an output, right? So the return should come. All right. So let's have let me clear this. I want us to write a function to do a simple computation. So we are saying that var sum. So that's the name of our function. The var sum is equals to function, and this is our, and we are saying that our function is going to take two parameters. So we want to sum two figures, right? We want to sum two figures. So which means that the function is going to take two items, right? Or two parameters. So I'll give it a parameter A and a parameter B. And this can be any name, right? Or any letter or any character. And I'll say that var C is equals to A plus B. And I'm saying that return C. So this is a simple function which is trying to tell, or which is trying to compute the summation of two figures. So anytime I want to compute the summation of like two figures, all that I need to do is to just come here. So let me just print something. So I'll say print, and I'll bring the name of the function, which is sum, and I open. Then the two figures that I want to sum. So I'll say 5, 5. Right? So I'm saying that find the summation of 5 plus 5, and it's 10. So you can see that. So anytime I want to do any summation, there's no need for me to write this 2 lines of code. I just have to call the function. The function is declared somewhere in our code. So I just have to call the name of the function. Then I'll say that, okay, function, these are the parameters, so do the job for me. And this, it makes your code more efficient and clean, more cleaner, right, than to repeat these items throughout your whole code. This is just a simple function that I've written, but I can have a function about, let's say, 30 to 50 lines of code. And you can't be repeating this 30 to 50 lines of code in your code each time you need to perform a similar function. You can just write one function like what you've written. Anytime you need, you call it, you pass your parameter to it, it does the job for you. Okay, let's go on. All right, so this is a typical example of a function, just like what I demonstrated, but this is another example. So the example says that we have a function, right? And the function is checking the length of a list, right? The length of a list. So what we are trying to do is, okay, let me come back. Sorry. So all the codes that you see here, I just placed the link here, which you can click on it and open it when you are revising or you are going through the session. So like that's the example that I was talking about. So you can see we have this function. The function is saying that the function takes a list, right? And we are saying that when you pass a list through this and the length of the list is greater than 3, it should print list has more than 4 elements. Or like else, it should just print list is less than 4 elements. So here, let me just make S3 less than. Okay, I think it's the same, 4 elements here. Okay, so anytime I want to do this, I want to check the length of a list. So like what we have there, the example I cited here, I have a list of images, Moody's, Landsat, Sentinel, Sentinel 1 and 2, right? And we want to check the length of this. So on top of my, or when you look at this, you can see, let's count it, 1, 2, 3, 4, right? The length is 4. So when we pass this image, like that's the list, the variable image that is holding this list, through this function that we've written here, it should return, it should be more than 3. Yeah, over here. If it's greater than 3, it should be more than 3. If it's less than 3, it should be less than 3 elements. So when I run the code, it should give me the list has more than 3 elements, right? So that is it. So because it's more than 3, it's 4, right? And this is a typical example. All right. And over here too, this is an example I also cited. And I created a list, and the list, the ee.list.sequence. Whenever you see this, it's trying to tell you that generate a list for me. And the list is from 1 to 10. So that is the range. Okay. So if you don't want to type 1, 2, 3, 4, 5, 6 up until 10, you can just use the sequence and you tell the function that, okay, ee.list, create a list for me, and I need the list to be between 1 and 10, and it's going to create that for you. Let me print something out here. Let's print my list. Let me just comment all the other prints so that we can see the outputs. Oh, my list is not defined. Okay, it's capital L. So you can see that my list is 1 to 10, right? And over here, the example that I wrote here, the function I wrote here, I was trying to tell the code that whenever you pass any list through this function, it should just take the values, right, and square each of them. So like square root of square each of the list, the items in the list. So let's say example, when you take 1, is like it squares it. So when you take 2 square is what? 4. 3 square 9. 4 square 16, right? So that's what this operator is going to do, right? So I do that and I map it to the list. And in my earlier submission, I don't know if you saw the PowerPoint presentation. One of the points I stated it in there that loops are prohibited. Oh, I think I've not got into that list that slide there. So loops are prohibited in F engine. Loops and else, if else, right? It's not efficient. So if you want to loop or apply, like loop through a certain list or a certain object and apply a certain function to it, the best medium to use or the best function to use is to use the map. .map. And it's just like when you see map, it's not this map. So this map is trying to tell the code that okay, we are passing this is a what do you call it, a function, and this is the function that we've created that lists our list function here. Sorry, forgive me. So the variable we have here, right, this variable, we are trying to map the function to this variable. So it's like you have one item here, the list, and we are applying the function to everything in the list, right? So the list will just go through all the items and apply the function to it. And I know we are going to, there is an example in the subsequent sessions that I will show you how it's being done. All right. So this will be like the end of the functions bits. So you'll be seeing a lot of functions in the subsequent session. So this is what I was talking about. Loops and easelves are usually prohibited in F engine, right? It's discouraged. So you can either use the map or the filter or the filters to do equally what these the loop and the if conditions performs, and the map and the filters are more efficient in F engine. And I would recommend that anytime you want to loop through a certain entity, a certain item, and you want to apply anything, you can use the map, and the map is more efficient than the loop. All right. So the last bit that I wanted to talk about in this introduction part and the basic GE part is hex. At times you see I think most of us on this platform are GIS and remote sensing inclined. And so far as you fall within this bracket, you are used to map, right? And anybody who is used to map is also used to colors, right? Yeah, and all these colors, they have their color codes, and this is the hex code. So usually you see a lot of code with a certain number, like what you see here. The hash 00000, that is black. The hex code for black, and the hex is always the code is always six characters, right? The hex code, they are always in 6 characters. They are always 6 characters, right? Yeah. So like I just placed some links here, and if you want to explore that, you can do that. So what you see here, these are colors, and each of these colors you see here has a code. No matter the gradients you see here, they have a code. And so, and the other, so in Earth Engine, you can either use the name of the color, the RGB code, or the hex color, so the hex color code. When you want to have, like, when you are defining your visualization parameters, the colors that you want to use, you can use any of these. If you know the name of the color, you can just type it in there. If you want to use the RGB code, it's accepted. Same for the hex code. Yeah, that is also accepted. So my last slide on this PowerPoint are some materials I placed here, and this will help you strengthen your JavaScript. And also there's a guide to take you through. If you're a beginner, this is new to you. It will help you familiarize yourselves with the Earth Engine interface. So the interface, like how the code editor works and all that, so that in subsequent sessions, you would catch up with the class, right? All right. So I'll move on to the next bit that I wanted to touch base on. That is our data exploration in Earth Engine. All right, data exploration in Earth Engine. So in Earth Engine, you'll be hearing some of these keywords: image collection, feature collection, right? So basically, an image, as we all know, as remote sensing and GIS experts or students or professionals, the image we see in Earth Engine, they usually are two-dimensional array of like individual picture elements, right? Which are usually in rows and columns, right? So like they are two-dimensional image. So they are in two-dimensional image, two-dimensional array. And as I explained in the previous slide, the array is what? A group of lists or a nested list. So it's a two-dimensional array, right? And that represents like individual picture or elements. That's like the pixels that are arranged in rows and columns. And we'll see that. So this is an example. So like this image you see here, the image you see here, when you zoom in into where this marker is, you get to see the pixel, right? So the pixel you see here, right? So these are represented by, is represented by this two-dimensional arrays of individual picture elements or individual pixels, right, that are grouped in rows and columns. And each of these pixels represents an area on the Earth. That's one thing that you have to bear in mind. Each of these pixels represents an area on the Earth, the area on the surface of the Earth, right? So let's say when you take a Landsat, we know Landsat has a resolution of what? 30. So when you zoom in, each pixel represents a 30 by 30 pixel, right? All right, so let's move on. And an image collection is a stack of images. So you can have an image and you have an image collection. So image collection is like a group of images stacked together, right? Stacked together. Okay. Before I continue, let's go to Earth Engine. Let me open a different tab. Okay, we are done using this, so I think I can just go. Since we are in our data exploration, I want us to have. All right, so when you go to earthengine.google.com, it brings you to this page, right? And you come to data sets, right? Come to data sets. And this is where you will see, if you want to read more on the data that they have in their repository, you can have access to that. So I'll click on view all data sets. All right. So as we can see here, these are some of the data sets that they have in their catalog. So you can see, let me scroll down. They have iStar data, they have DEMs, they have, so these are like DEMs, data map of oil plantations. They have, let me scroll down. So like these are like data sets that are made readily available for your analysis or any kind of analysis that you want to do or any research that you want to do. These are like pre-processed images. So you have the Sentinel-2 multispectra, you have Sentinel-2 cloud probability, and each of these image, before you use it, I will recommend that you read about the data that you are going to use, so that at least you have a fair idea of the data, the range, the when the data was captured, like the basic information or the metadata behind that data, right? All right. So like there are a lot of them. Sentinel 1, 2, 3, we have 5. And these are like data sets that you can also explore. Same for Landsat. So when you come to the Landsat tab, we have the recent Landsat, that's Landsat 9, which was launched somewhere last year. And we have that data from the last year when it was launched to date. You can get that data. Same for Landsat 8, Landsat 7. So usually when you are running an analysis, right, and you know the data range or the date range that your analysis is supposed to run, you should bear in mind the kind of data you are going to use. So let's say you want to run something from, let's say, 2015 to date, then you can always leverage on Landsat 8 because the data archiving was started in 2013. But trust me, in some parts of Ghana, when you go in there, there are no data sets for 2013, right? That's one observation I've made. Even though they are saying it's 2013, in some parts of the world, you get the data for 2013. But in some parts of Ghana, especially in the remote areas, it's difficult to get data from that date range. Yeah, but if you are lucky in some of the urban areas, you can get images. Yeah. And so depending on the kind of analysis, you check when the data was injected. They started injecting the data so that at least you can select the right image for the job, right? All right. Let me just click on Landsat 8. I want us to check something out since we are exploring our data sets. So when you click on Landsat 8, we have different Landsat 8. We have the surface reflectance, we have the top of atmosphere. So depending on what you want, and as I said, before you use any image, click on the image. So let's say we want to use surface reflectance. When you click on it, all the information that you need, what the data, like how the data was even, what the data is about, how it was pre-processed, and all that, you can get those information here. If it meets your standards for your analysis, you are good to go. You have the bands, so you can also see the bands in which the bands that are stacked together in that particular image, right? So that when you are calling the bands, you know the right names to call. So you can see surface reflectance. It now has SR underscore B1, SR underscore B2. Yeah, so if you want to call B2, you call SR underscore B2. You don't call just B2. I think recently they did some modification in some of their metadata, because I remember I had a script that was running and I was calling B2, but I think some time ago, yeah, if my memory serves me right, I was running the same script again, and it prompted me that this is deprecating or something like that. So it's now, so it made me go to that image, the metadata of that image, and I realized that now they are changing. So that script is old now, so I have to make sure that I remodify the the code to meet the 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 sorry, to meet the new standard that has been set in the metadata. And these are some of the things that you have to look for, because with every data, and when it comes to the image, every image has properties, right? So all the images you see injected in Earth Engine, they all have properties. So the properties are like the cloud cover, the cloud cover land, and they all, it's like there's a description to it. So you can just go in there, explore. So maybe you want to select an image, and you want an image with maybe a cloud cover less than, let's say, a cloud cover, 30% cloud cover or 20% cloud cover. You know the right property to call to filter the image out for, right? And all these are properties that you can filter the image with. All right. And there are always terms and conditions, right? If you are using Earth Engine for a commercial use, you better get a commercial license. But if you are using it for a research or your thesis, I think you can use it for free. But if you are using it for a commercial, you are using it for commercial purposes, then I recommend you go for the commercial license. Yeah, that is the right thing to do. All right. And with every image, usually when I'm teaching Earth Engine, I always advise my students not to try to cram the codes in their head. Try to memorize the code. Try to understand the basics, right? When you understand the basics, then the other things will follow. But when you see any code, because you have the basics, you're able to interpret the code and you're able to modify the code to meet your needs, right? So Earth Engine has made it possible. So every image that they have in there, they've always provided a sample image, a sample code to do it, to load the data, and if possible, at times they even add a function that will help you remove the clouds, right? And this is a typical example of a sample code to load this data. So let me just open this in a code editor and let's see something. So that's the code. So over here, they are calling the data by the ID. So every image has an ID, or image collection has an ID. So like this is the image collection. Let me copy this. And that's the Landsat 8, yeah, top of atmosphere. Yeah, that's yeah, Landsat 8, yeah. So this is the image that we reloaded. So let me just click on run to see how that image looks like. So you can see the image in here with a lot of clouds here. Yeah, so you can just zoom to your area of interest. Then if you have your area of interest data, you can load it into it. Then you can do the clipping, which I will teach that. Or this illustration is just to show you how to explore the data, how to get certain information. You don't need to write certain codes. So like these codes are always on their site. If the data that you need to you want to load, you go to that data. So let's say let me take this data. I usually use this data a lot. The top of atmosphere. Okay, so when it comes to this data, it has the same description, the bands. So you can see that this image, the bands are B1, B2, but the other one has the surface reflectance had SR underscore B1, SR underscore B2. So yeah, when you're writing a code and you think maybe the same code can be applied to the other image, you have to be mindful of the bands that are being used. If you are modifying the image, the code, you have to make sure that the properties are matching with the right image that you are using. Okay, that is one caution that I would like to also highlight when using someone's code or any code that is you chance on online. All right, and we also have the Moody's data, which you can also explore. These data sets are there for free. You can just go in there, extract your area of interest, and use it for your analysis or your research. Okay, let me come back here to all data sets. And Earth Engine also has a public repository where anyone at all can go in there to upload a product that each like the individual wants to share with the world, right? So some of these data sets are coming from people's projects. So let's say I've been able to run a project. Let's say I have a drone image over Ghana, and let's say I have the resolution is, let's say, a centimeter, which is very it's not easy to get such an image. It's very expensive to get such an image, right? And maybe I've been able to run analysis, use land cover using that image, and I want to share with the world so that anybody, since you are in the open source era, you want to share with the world, you can generate the product and come and dump it here. And when maybe if another person is also running any research and the person wants to use their data sets, the data can be used and you will be referenced in their project. All right. Okay. Let's come back to our slide. It's already 8. Let's do something before we go. All right. So as we can see, so the image collection is like a stack of images, right? As said earlier. All right. So if you want to search for an image, as I've already showed you how to search for an image, and I'll just skip this slide. I've already explained this. But the only part I didn't explain is also you can also search for the image here. So if you maybe you need a Landsat 8 or Landsat 9, you can just type in here Landsat 9. Then if the data is available, it will just pop up here and you can just select the data. Then as usual, you can import it, or you can also see an example of the data, and it's going to just write the script to load the data set, right? So as you can see here. So when I run the data, so that is the image, the Landsat 9, right? Okay. So you can see with this image, the visualization parameters, they use the true color, that is the RGB 432, right? So they use the B for B3, B2, that's the RGB. All right. So at this point, I will bring my session to an end. Then we will continue, God willing, on Monday. Monday, we will start loading the data sets, adding the visualization parameters as you see here. Then we can dive into the data exploration bit. Then try to run some of the spectral indices that you could think of. Yeah, and the most important aspect that you need to know, with this all these spectral indices, the formulas are there. You should know how to write the formulas in Earth Engine, and it's going to just like the moment you're able to write the the same formulas in Earth Engine, the work is done. Right? So just understand the basics, as I keep stressing on, so that some of these things will be easier for you. Yeah. Okay, so at this point, I'm going to open the floor for questions. Then we can end the section for today. So we have like 2 sessions left for this mentorship program. When we meet on Monday we'll be doing 2 hours. Then Thursday we'll be doing 2 hours, and we'll finish the session for the mentorship program. So God willing, next week Thursday will be our last day for the mentorship program. So the following week, maybe the following Monday, we'll have an open house session where like questions and like suggestions for our next program that will come in next year. What you think we should add, what you think we should just take it off, like those kind of feedback. That will be next 2 weeks, Monday. Okay, so that will be our last session for the mentorship program. Then we'll go for our break. Then, God willing, next year, based on the feedback we get, we'll know how to structure things and come back. All right. So thank you very much.